Hi guys, this is another update on my VKEngine project, and it should be a good episode this time because it's the first time we're looking at our 3D model. And of course, for that to be possible, I've also set up depth testing using a depth buffer, and additionally I've enabled mip mapping and multi-sample anti-aliasing to increase the fidelity of the image a bit more. So if we take a look at a visual presentation, you can see the 3D model spinning around here. It looks wrong from the back because this model was only designed to be viewed from like this angle, so there is no geometry around here. But you can see that the texture is being applied to the model correctly, and it's also running 4 times multi-sampling and mip mapping. And the overall image fidelity looks pretty good, especially on my PC. I'm sure YouTube compression is ruining it a lot, but you get the idea. Okay, so what am I going to do next? Obviously, loading a 3D model is a good place to checkpoint the project and kind of take stock of where I'm at. So my medium-term goal, as I said in the initial video for this project, is to implement the rest of my features from my OGL renderer project, so my OpenGL renderer. And that had features such as physics-based rendering, image-based lighting, other kinds of lights like directional light, point light, spotlight, maybe even area light, that'd be good. And some kinds of shadows, and then some sort of scene where you can move around, add stuff, and a camera. And post-processing, so some HDR, some exposure, and maybe add some bloom, screen space ambient occlusion, that sort of thing, right? Not like cutting-edge graphics techniques, but just standard 3D graphic stuff. And I'm not going to jump straight into doing this work though, because I want to kind of deepen my understanding of the Vulkan API some more, because I feel like I have a grasp on Vulkan now, like at least like a tenuous grasp, right? But definitely I don't have a good, strong grasp on it yet, so I want to take some time to read around the API a little bit, and especially looking at something like Sasha Williams's Vulkan samples, and also this textbook I purchased, the Vulkan 3D Graphics Rendering Cookbook, which I definitely recommend, to just gain a deeper understanding of the API overall, and make sure that I'm implementing things well going forwards. And then, of course, I'll keep posting videos as I keep doing the above work. And once I've kind of gotten to that state, my goal is to kind of progress towards more state-of-the-art things. So looking at like mesh shaders, hardware ray tracing, temporal anti-aliasing, deep learning supersampling, that sort of thing, right? Okay, so let's talk about some technical details. And if you're not interested in technical details, you can just stop watching the video at this point. So in OpenGL, if you want to implement depth testing and multi-sample anti-aliasing and mip mapping, it's very trivial, right? We just run these lines of code. In Vulkan, it's far more difficult. So these slides are a high-level overview of how to implement these features in Vulkan, assuming that you're using dynamic rendering. And it might be helpful to you as like a supplement to the Vulkan tutorial. So feel free to just pause the video and read through the slides in detail for the implementations of depth testing, mip mapping, and multi-sample anti-aliasing. I was going to include some source code in these, but it's just far too much information. So if you'd like to contextualize it a bit more, you can just check out my full implementation on my GitHub. And then I do maintain a list of resources on how to learn computer graphics on my personal website. So check those out if you're interested. And I guess I'll wrap up the video here. So thanks for watching. If you're interested in following along the development of this project, feel free to subscribe. And I'll probably be back in about a week or two once I wrap my head around the API a bit more and add some more features to the engine. All right, so until then, thanks for watching.